Hello and welcome to R&D Mathematics. Today we are going to talk about dividing polynomials. Dividing polynomials. Now, today we will be talking about long division. Actually, I always prefer long division because it works in all the cases. Now let's recall something simple. Let's say that we have to divide 22 by 4. Now if you are using the long division, we write it like this, division and 4 here. So we call this guy the dividend or dividend, and this divisor. And 4, so we write here the number of 4s we required for 22, and we know that is 5. So 5. Then we multiply 4 and 5, 20. Then we subtract these numbers, we get 2. Then we express 22 over 4 is 5 times and plus 2 over 4, right? So dividend divided by divisor equal the number we get here, we call it quotient plus this guy to remainder over again divisor. Now the same principle we are going to apply for polynomials. Now let's have a look at an example. 2x cubed plus 3x to the 4th plus 4 plus x squared divided by x squared plus 1. Now how are we going to do this? Well, actually the first step would be write down the polynomial in standard form, because if you have a careful look at the denominator, it's not in the standard form. It's not starting with the highest power. See, highest power is 4. So we may write the highest power first. We want to write the highest power. We must write the highest power first, and then next higher 2x cubed, next one x squared, and next one 4 divided by x squared plus 1. Even with the denominator, if it is not in the standard form, make it into the standard form. That is the first step. Second step, you draw these two lines exactly like before and place your dividend inside it and divisor outside it. Okay, that's the second step. Next, what you need to do, first, this term, the highest power term, and the highest power term over here, you check how many of x squared or from what you need to multiply x squared in order to get to 3x to the 4th. So I need a 3 obviously, and I need another x squared. When I multiply these two terms, I will get 3x to the 4th, right? So the next step, you actually multiply these two numbers and write it underneath this. So 3x to the 4th, that's those two terms. And then with this plus 1, when I multiply 1 by 3x to the 4th, I get 3x squared. Now you have to be very careful here. I can write 3x squared here, but now the next step is actually going to be I'm subtracting. See exactly what I did here. I'm now doing it with x and x's variables. So I'm going to subtract, but if you write 3x squared, write here we have a problem because it might make, yes, you can do it like that, but there is a nice way. Here, see, 3x squared. Write down that x squared term underneath the same term, x squared term. So instead, here we have, in case you will have a cubic term, yes, you can write it just after 3x squared term, but in now we don't have any. So I will write it over here, 3x squared. Oh, actually it's better to put my plus sign also over here, right? So what I did was, for the first highest power term, I looked at the highest power term of the divisor and see how much I need, and I put that number over here, then multiply my divisor by that number and write it underneath my dividend. Now subtract. So 3x to the fourth, 3x to the fourth, that will cancel. That always will happen. 2x cube minus, you don't see any x cube in your result, so 2x cube. Then x squared minus 3x squared, that is going to be negative 2x squared. 4 minus nothing, or 0, so 4. Another trick is, you can just fill these things with zeros if it makes easier. Now the next step is, look at the highest power term, do the same thing. How many of x squared you need to make that? So now I need a 2 and I need another x. Then multiply 2x by your divisor, this guy, so this whole thing. 2x into x squared, I get 2x cubed. This first term will always be the same. Then plus 2x. And again, now we have problem, plus 2x. Let me write plus 2x over here. Now the real question is, here you don't see, you have to be very careful guys here. You don't see any x's in your, see in this one you don't see any x's. One thing I suggest, I should have told this in the beginning, you could have done this plus 4 right slightly over here. So I will have to write this 0 also over here, and then this plus 4 also over here. Since you don't have any x's, put 0x. So here 0, and here you have 0x plus 4. So now you subtract. Then 2x cubed minus 2x cubed, it's gone. Minus 2x squared, and you don't see any x squared here, so 0x squared, it's go, so it's 2x minus 2x squared. And 0 minus 2x, so it's minus 2x. Remember, you are subtracting, right? That's why this minus signs appear, and here there's 0, so plus 4. Again, do the same. So for this, I need minus 2 of x squared, this guy. So then multiply minus 2x squared minus 2, and I write it over here because I don't see any x terms appearing when I multiply it. Now I subtract, minus 2x squared will vanish, and then minus 2x, and you don't see any x term, so it comes over here like minus 2x. 4 minus minus 2, and that's 6, plus 6. And that's far as we can go, because now the power of this term is less than power of this term. So we are actually done. So all it remains is to express what we did in a nice form. So 3x squared, 3x to the 4th plus 2x cubed plus x squared. You don't need to write 0x, you can just write 4 divided by x squared plus 1 is going to be this guy, quotient. So 3x squared plus 2x minus 2, and then plus something over something. So the remainder, this guy, negative 2x plus 6 over x squared plus 1, and we are done. Okay, I think you need more examples, so let me do one more. So there are places you have to be very careful when there are no powers, when they do not exist. You have to be careful. Let's do this example, a simple one. X to the fourth minus 9 divided by x squared minus 1. Okay, x to the fourth. Now in this case, x to the fourth plus x to the cube, because there are none, there are none, there are none, finally minus 9. That's advisable to write it like that. You don't have to do it with the device, you just can do it like this. Now to make x to the fourth, I need x squared, and I multiply, I get x to the fourth minus x squared. So minus x squared, place it underneath x squared term, right? Then no confusions. Then you can easily subtract. So you get x 0 x cubed. You don't need to write that, so just 0 and x squared. Pause the video and try it yourself. Okay, so x to the fourth minus x to the fourth, it's gone. 0 x cubed, and here also you have actually 0 x cubed, so no x cubed term. And next one, 0 x squared minus minus x squared, so you have plus x squared, and plus 0x minus 9 minus nothing, that means just minus 9. And at this point, I need plus 1 in order to make this guy with this guy. So when I multiply 1 by my divisor, I get x squared minus 1, and I should write it like this. So now when I subtract x squared minus x squared, it's gone. 0x minus 0, nothing, that's just 0. Minus 9 minus minus 1 minus 8. And we are done. So x to the fourth divided by x squared minus 1 equals the quotient x squared plus 1 plus remainder over divisor. We can explain it like that. Okay. Negative 13 x squared plus 4x to the fourth plus 9 divided by 4x squared minus 9. Now I'll teach you something. So the highest power, 4x to the fourth, you write that first, plus 0x cubed minus 13x squared plus 0x plus 9 divided by 4x squared minus 9. Now I need x squared in order to make 4x to the fourth by 4x squared. So I multiply them, I get 4x to the fourth minus 9x squared. I should write it underneath my x squared term. Then subtract. Guys, if it is hard for you to subtract, you can do this. And then 4x to the fourth minus 4x to the fourth, it's gone, and you only have minus 13 minus minus, so plus or minus squared. And you just can rewrite these terms because there are nothing underneath it, like here. Now I need minus 1. Now I have here minus 4x squared. Now I need minus 1. Yes, minus 4x squared. Minus 1 minus plus 9. And as you can see, this is perfect. Why? This term and this term, they are the same, so the remainder is 0. So this is a nice example. So 13x squared plus 4x to the fourth over 9. 4x squared minus 9 actually equals to that one. No remainder because remainder is 0. In other words, this guy 13x squared plus 4x to the fourth plus 9 has factors. It looks like it's having factors, and factors are, see, when I cross multiply this one by this, squared minus 1 into 4x squared minus 9. Now actually, let me show you something. Let's take a quadratic equation. You know how to factor quadratic equations, right? So let's say x squared minus x plus 12. Now in this one, you know already 12. So I need 4 and 3. And I need a minus, so minus 4 into, no, here it should be minus. Let's say minus 12. So minus 4 into minus 3. So x minus 4, x plus 3. These are the factors. Let's check. X into x, x squared. Minus 4x and plus 3x, I get minus x, and minus 4 into 3, minus 12. Correct. Now, let's have a look at this in a different way. What if I ask you to divide x squared minus x minus 12 by x minus 4? I must get this. Let's check. X squared minus x minus 12 divided by, okay, I need an x, so it becomes x squared minus 4x. Now I subtract, so minus x minus minus 4x, I get 3x, because minus minus, that's plus, and you can just write down that. For 3x, to make 3x, I need plus 3, but when I multiply this term by 3, I get 3x minus 12, and the remainder is 0. See? Okay, I think now everything makes sense, right? So that's enough for this video, guys, and thank you.